Woohoo, we are live. This is Math 40, elementary algebra. And anytime you see the word applied or applications, you know we're in for a good time. So because of that, I brought in some other support animals. I got my squirrel and my shark. I have no idea what it's my collection of puppets and a calculator. You're really going to want a calculator for this because we're going to get very serious with some 1 3/4% percents. And so, make sure you have a calculator somewhere, even if it's just part of your phone. Also, I'm going to remind you from the last video, percents are like cents or dollars. 10 cents or 10% is $0.10 or decimal. So the cents and the percents and the dollars and the decimal are on either side. 5 cents is like 5%. It's $0.05 or 0.05 in decimal. So just try to remember that. And let's go for it. Woohoo, word problems. Okay, a guest at the San Antonio Hilton Airport Hotel paid $180 for a room. So I'm going to start taking notes. The room was $180. Plus, there was a 9% city room tax, 9% city room tax, a 1 3/4% county room tax, 1 3/4% county room tax, and a 6% state room tax, 6% state room tax. A lot of taxes. Find the total amount of tax that the guest paid on the room. Okay, so I'm going to read it again. A guest at the San Antonio Hilton Airport Hotel, interesting but not useful, paid $180 for a room. Bam, there we go. Plus 9% city room tax, there we go. 1 3/4% county room tax, got it, and a 6% state room tax. And what we want to know is the total amount of tax that the guest paid on the room. And so here's the question. When you pay taxes, do they stack up on top of each other like that, or are they applied separately? And you may not know. You may say, I have no idea how taxes work. And what I'll tell you is they are applied separately. So each of the taxes is multiplied just times the room. You don't like stack them up all multiplied together. So what does that mean? Well, so it means that there is a city tax. That's 9%. So I'm going to convert that to our decimal. 9%. And remember, I moved the decimal point 2 places. 0.09 is the decimal. And what I do is I take the 0.09 and multiply that times $180. So let me move this. Let's see. I'm sorry. I'm going to have to move the squirrel a little bit. Can you guys see that? Yeah. Good. 0.09 times 180 equals 16.2. 16.2. Now that's not going to make a lot of sense in terms of dollars. That's not the way we measure dollars. The way I'm going to write it is $16.20. Does that make sense? So that's the city tax. Kind of woohoo. Shall we go forward? County tax. Now, we do not add this on to the 180 to keep going. When we look at the county tax, that's 1 3/4%. So I'm going to write that as 1.75%. Move the decimal point 2 places, 0.0175. And then I'm going to take that 0.0175 times the 180. So I've got 0.0175 times 180 equals, and that's going, I can't see it, 315. So that's equal to $3.15. So far, so good. Woohoo. Okay, last one, state tax. Ding, ding. The state tax is the winner. So 6% is going to be written as 0.06. And I multiply that times the 180. 0.06 times 180 equals, and this one's going to be 10.8. And again, I'm going to convert that to something that makes sense in terms of money. And then the total tax, I'm just going to add them all up. I'm going to say it's 1620 plus 315 plus $10.80. And the total, 16.2 plus 3.15 plus 10.8 equals, and I think I get $30.15. Okay, so that is how you calculate it. Now, some of you may be looking at me going, what are you even doing? Why didn't you just add them all together? And the answer is, in this particular case, you could. So what you can do is you can take the percentages and add them up, either as percents or as decimals, your choice. I'm going to do it as decimals, 0.09 plus 0.0175 plus 0.06. So our total taxes are 16. Can you guys see that? Kind of 16.75% or 0.1675. If I take that and I multiply that times 180, can you see? $30.15. So in this case, where you're calculating tax a bunch of times and they're all separate, you can just add all the tax rates together and multiply once. That's actually the distributive property, believe it or not. So our final answer, because they just want the tax amount, is that. Not too bad. Woohoo. We did one of the 4 problems. Yay, congratulations. Let's keep going. Number 2. Now this is such an important concept that number 2 and 3 are basically the same problem with just a slight tweak. So, a pearl necklace of former First Lady Jacqueline Kennedy Onassis, originally valued at $700. So originally it was $700, but that was way back. Was sold at auction in 1996 for, holy cow, $211,500. And we want to know, what is the percent increase in value? Ooh. Now, if we were in class together, so first off, I'm going to bring in my support animals, my support shark and my support squirrel, and we'll all huddle and, hydrate and all that. I would say, let's all just brainstorm. So let's brainstorm. I know I need to know an increase, and I may not know what the percent increase is, but I could look for the total increase. Why don't we look for the total increase? And another way to look at this is it's called the total change. All right, how much did it change? In this case, it went up. So how do I figure out how much the increase was? You're right. I take the $211,500 and I subtract the $700 it was originally. And then I get, what is that? I don't trust my brain right now. So we're going to do 211,500 minus 700. It's just going to be just over 210, right? $210,800 is the total increase in value. Okay, so that's the total increase. And the question, it turns out, find the percent increase in the value of the necklace. is actually phrased this way. The increase is what percent of, and what do we compare it to? We compare it to the original. Okay, so the increase is what percent of, let's see what color haven't I used yet? I haven't used green, of the original. Okay, so let's put this together. The increase, 210,800, is equals what percent? I'm going to need a percent. And again, I'm going to do this the way that the book does it, P over 100. You don't have to. You could just do it as P. That would be fine. Of times the original, which was, the original was 700. So it looks like that. Okay, so 210,800 is equal to P over 100 times, and then I'm going to write this one as 700 over 1 to make it easier since we're in fraction land. Again, the percent is percent, so over 100. I can cancel this 100. I've got a 7 up here and a 1 down there. So I've got 210,800 equals P times 7. And then what am I going to do? I'm going to divide both sides by 7. You're right. 210,800 divided by 7 equals P times 7 over 7. And I think this is going to get too squashy. So let me go to another page. And I'm going to copy this down. 210,800 all over 7 equals P times 7 over 7. Okay, so let's take a look at this. The 7s, obviously, they cancel. Yay! And then I get P equals 210,800 over 7, or P equals, I'm flipping it around to make it easier to read. Clear 210,800 divided by 7. It's probably not going to be nice. Oof, that is 3,011,4.2857 and some other numbers. Okay, so what does that mean? Let's take a look again here. Let's look at where we came up with it. So P is what percent? Okay. So the P is already in percent. P is already in percent form. So P, and let's go ahead and round it to a whole percent. And again, I would need to tell you. So the problem should have, I copied this out of the book and they didn't tell us how to round, and I should tell us how to round. So let's say I want you to round to the nearest whole. So let me write this in. Round to nearest whole percent. So that's going to be 3,0,114. The next one is 2, so I keep it at 4%. So in other words, we're talking about 30,114% increase. This is bonkers. But that makes perfect sense, because if I look at this, if I say 211,500 divided by just straight up 700, it's 300 times as big. This is 300 times as big as it was. So it makes sense that it would be 30,000% increase. Kind of, sort of. These are the mind-boggling numbers. Okay, I want to do another one. This will help us. This will help us cement this. The increase is what percent of the original? We're always comparing to the original. These numbers are slightly less gigantic. A pair of shoes that usually sells for, so originally, it sells for $110, was marked down, so here's a sale price, to $88. Find the percent decrease in the price of the shoes. Percent decrease is what? Okay, so let me read it again. A pair of shoes that usually sells for 110, there we go, was marked down to 88. Find the percent decrease in the price of the shoes. Okay, so when we look for percent decrease, this is the sentence we're setting up. The decrease or the change is what percent of the original. And if you want a generic one, you could call this the change. So instead of the increase or the decrease, you just have one that always works. Okay, green, green, yellow, yellow. I don't know if I'm using in the same color, same order as before. I'm just picking different colors so you can kind of see the different parts moving of, and then the original. Okay, so let's go through. I know a couple of these without even having to look at the problem. Is equals of multiplication. Do we know the original price? Yes, it was 110. Okay, what percent? I'm going to do P over 100 again. Okay, and now do I put 88 here? This is where 88 goes. And the answer is, oof, this is a trick question. And the reason it's a trick question is we just want the decrease. We don't want the sale price. We want the change. So the decrease, which is the change, is the difference. And difference literally means subtract. So that's going to be 110 minus 88. So I think that's 22, but again, I always oops. Let's try that again. I shouldn't try to use a calculator without paying attention. There we go. Woo, 22. So the decrease is 22. Notice 88 never shows up anywhere. Okay, so the decrease is what percent of the original? Okay, so I got 22 equals P over 100 times 110. So this one's not going to be as easy as the previous one. I can knock off one of the zeros, but I can't knock off both of them. So I get 22 equals P over 10 times 11. Now, there are a couple of ways we can go with this. So if we want, we could bring these two together. We could multiply everybody by 10. We could divide everybody by 11. We got lots of choices. Since we were just talking about this in the last section, I'm going to go ahead and since there's a fraction, I'm going to just multiply everybody by 10. So 10 times 22 equals 10 over 1 times P over 10 times 11. Remember, because this is multiplied, it's just one term, so I just have 110. Let's see, what color did I not use? Red, orange, yellow, green, blue. So I got a 10 on the left and a 10 on the right. I cancel the 10s. And let's see. Over on the left, I've got 10 times 22. Over on the right-hand side, I've got P times 11. So basically, I took that 10 that was in the bottom on the right, and I moved it to the top on the left. That is kind of how things work. Here I've got 220 This is 11p. What would you like to do? Yeah, let's divide by 11. 220 divided by 11 equals 11p divided by 11. Oh my goodness, I'm running out of room. Let's see, can I do it? Maybe not. 220. 220 divided by 11. Looks like it goes in. Yep. 20 equals p. So my answer, the p, which is the percent, is 20%. The decrease was 20%. $22 represented 20% of 110. So you saved 20% on your shoes. Woohoo! Oh my gosh, I'm excited. Are you excited? There's only one more problem in 2.3. This is very, very exciting. Woohoo! Okay. A pair of pants that usually sell for $40 are on sale for 25% off. On top of that, you have a special coupon for an additional 25% off all sale items. Do you end up saving 50%? So if you recall where we started with all of this, way back when we were staying at the San Antonio Hilton Airport Hotel, I said you can take all the percents and add them together because they were applied separately. So the question is this the same situation? And the answer is no. Why? It's a good question. Why not? I already put yellow on it. I'm going to put pink on it too. I'm going to really, on top of that, you have a special coupon for an additional 25% off sale items. So what does this mean? This means that when you apply, and this is going to depend on the store. Some stores do it in different ways, but generally speaking, this is the way a store will do it. You have the original price, which was $40. So the first sale, the 25% off, this is what you do. You take 25% off, which means we're looking at 0.25, right? So we take 0.25 times the original $40, and that gives us, and it should give us 10. There you go, 10. So you save $10. So we've got $40 minus $10 is $30. This is the sale price. Yay. Good deal, 25% off. I'm not going to complain. Now, the coupon, an additional 25% off. So we're going to look at 0.25. So I'm going to take 0.25 times the new price, the 30, and I'm going to get 7.5. So 30 minus 7.5 is 22.50. Did I save half? And the answer is no, because what's half of 40? Pardon me. So why is there a difference in price? So let's look through, because this is something that happens like in the quote unquote real world. This is one thing that happens and people are always like, oh, math doesn't make any sense. And the answer is math makes sense. Sometimes marketing doesn't make sense. So when we took the original 25% off, 25% of 40 was $10. So we saved $10. Great. Now the price is 30. So when we save an additional 25%, 25% of 30 isn't 10, it's only $7.50. So we did not save the full $10 the second time because the 25% was applied to the sale price, not the original purchase price. Does that make sense? So it was slightly less. So if you're saving 25% of something smaller, you get a smaller discount. So this is why sometimes people are like, oh yeah, I'm going to save 50%. And the answer was no, not quite, because the second discount isn't as high as the first one. Now, this is a case where they're stacked one on top of each other instead of separately. These are stacking. So this is why this is different. So whenever you're coming across word problems or in the real world, if you've got 2 coupons, ask the company, ask the store, am I going to be able to apply these separately, or do they come one on top of each other, which is usually what the company will do, because that way you spend a little bit more. Okay, woohoo, we did it. You made it through. This was a bear of a section. You guys did it. You're awesome. Dancing time. Da, 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 da. Okay, we're done. So, woohoo, next up, we're going to be doing 2.4, which is all about formulas, which is going to be super fun. I will see you there. Same bat time, same bat channel. Math on, guys.